I'm on page 62 of the text if you want to follow along. Inequations are just equations, but instead of an equal sign, you will see an less than sign or a greater than sign. In your head, you need to figure out a method of remembering that this one here is less than, and this one here is greater than. The way I remember one of them, I remember that this one is the less than sign. And it's just that one, that it's a funny way of remembering it, but I find this one, the natural one that I draw, I always draw the less than sign. And I just remember that one is my less than sign, and then I just remember that that is the greater than sign, the opposite of the less than sign. Okay, that's the first thing. So as I said, it's identical to solving equations that have equal sign, apart from one catch. The catch is when I multiply or divide both sides by what? Anyone know? A negative. Oops. Then the inequality changes direction. Let me explain what I mean by, I'll do an example. Okay, so for this subtopic, you have to remember that statement. When I multiply or divide by a negative, the inequality changes direction, right? From a less than to a greater than, or a greater than to a less than. Here's an example. X plus 2 is always greater than 3. Right, solving. Think of the inequality as an equal sign, and you can do that, and you can solve this no problems. X normally would equal to what? 1, because you subtract 2 from both sides. But it's not an equal sign, it is a greater than sign. So how this reads is, as long as X is greater than 1, the inequation will always be true. For example, a number greater than 1 is 5. 5 plus 2, right? 5 plus 2, 7, which is greater than 3. Think of another number greater than 1. 10. 10 plus 2, 12, is greater than 3. If you put the smallest number I could put in according to my answer is 2. You can't put 1 in because it has to be greater than 1. So the smallest answer I could put in there would be 2. 2 plus 2 is 4, which is true. 4 is greater than 3. So that's how this works. Now let me show you an example how the inequality sign changes if I divide by a negative. I'm looking at question 4 on page 62, and it reads like this. Minus 3x is greater than or equal to 6. That's the question. To solve this problem, think of the inequality sign as a negative and do the division. Think of it as an equal sign, right? And do the division. Now, because I'm dividing by a negative, I'm dividing by negative 3, the inequality sign changes from a greater than sign to a less than sign. Here it is. X is not greater than, it is less than or equal to, what's 6 divided by 3? 2. And it's negative. It's negative. A positive divided by a negative is a negative. Check my answer. Negative x has to be less than or equal to negative 2. Less than negative 2 would be negative 3. Right? Put negative 3 into here. Negative 3 times negative 3 is positive 9, and positive 9 is greater than positive 6. It works. Choose another number that is less than negative 2. Say negative 5. Put negative 5 into here. Okay? Negative 3 times negative 5 is positive 15. Positive 15 is greater than positive 6. So you can see my answer is not singular. It is actually referring to a set of numbers that will solve the inequation. Usually our answer, there's only one solution for x. However, in this instance, there's infinite solutions for x. Okay, this inequation, has x on both sides. The idea being that I try and collect my x's on one side of the inequation. To do that, I could try and get rid of that 2 by dividing both sides by 2. However, I'd wind up with a fraction on the right hand side. I don't want fractions, I don't like them. So what I'm actually going to do is I'm going to first of all multiply my 2 out by both those terms, just like we did in manipulation. 2 times x, 2x. 2 times minus 4, negative 8, is still less than 3x plus 8. There are different ways of getting to the answer from here. Remember, I like to collect x's on the side where there's more of them. Yes? So perhaps shifting that 2x onto the right hand side by subtracting it would be a good move. I'll do it that way, and then I'll show you what would happen if I did it the other way. Okay? So subtracting 2x from both sides. Okay, that's a minus 2x. Minus 2x. Both sides, as long as I do the same thing to both sides, we've got a seesaw that stays in balance. So on the left hand side now I've got minus 8. And on the right hand side I've got, what's 3x minus 2x? Just x, eh? Hey, that's good. 3x minus 2x is just 1x, or x. And then I've still got my plus 8. Okay, so now I've isolated x to one side of the equation. Very handy. I'm going to shift that plus 8. Okay, I'll carry on up here. I'm going to shift that plus 8 by subtracting 8 from both sides. Okay, again, anything you like, as long as it's done to both sides. And on the left hand side I'm left with, on the right hand side I'm left with x. On the left hand side, minus 8 minus another 8. Good, negative 16. Now, you don't usually read in maths the number is less than x. You normally read x something, the number. So I'm going to flip that over and watch carefully. Everyone watching carefully. The mouth of the alligator is pointing at the x. You need to keep the mouth of the alligator pointing at the x if you write it the other way around. X is greater than minus 16. So keep the alligator still pointing at the x. Okay, and that will be my answer. X is greater than minus 16. Again, you can test it. I'll try I'll try test it with positive 1, because it's an easy number to work with. Positive 1 is greater than negative 16, so it should work. Put a 1 in here, put a 1 in for x. Okay, 1 minus 4 is minus 3. Minus 3 times 2 is... Minus 3 times 2 is negative 6. 3 times 1 plus 8. Now, what this reads is minus 6 is less than 11, if you work it out with the value 1. And that is true. Minus 6 is less than 11. So, okay, I'm only going to test it with one number. You could go and test it with a whole bunch of numbers. But it does work. X has to be any number that is greater than... It can't be minus 16, can it? It's not greater than or equal. Has to be greater than. You would, if the question has an equal sign there, you just carry on the equal sign everywhere, right? If it doesn't have an equal sign, you just deal with the greater than or less than sign all the way through.